must be somewhat confusing to learn that we have two very different ways of trying to understand what visual perception is. We've spoken of the internalist and the relational approaches. By the internalist, we mean those approaches that assume that the world is projected onto the retina and the brain makes sense of it. So there's a separation of the subject from the world. And such theories fit well within the computational theory of mind. They are ubiquitous. Such theories are ubiquitous, but they're not the only ones. When we looked at the ecological approaches or relational approaches, we saw we were concerned not with hypothetical goings on inside the head, but with the nature of the interaction between a fully embodied being and the world. So on the top left there we have Alex with his eyes wide open, forced to sit and consume images in Clockwork Orange. And in the middle we have that, I think it's going to move for me, there we go. We've got that sense of walking down through the woods, and there's a play of light on the retina and the world comes into being, but without any imagistic quality, without any frame. The thing is, these two are necessarily incomplete because when we say, I see something, we mean a lot of different things. And there's no chance of ever having a single theory of what it is to see that can accommodate all the meanings that we mean. So there's a pink elephant up in the top right, so you can see things that aren't there, for example. Or you can have a, let's say, idiosyncratic interpretation of what you're seeing, which doesn't accord with everyone else. There are many other senses of seeing. Let's just have a look. Assuming that seeing is something that goes on while you're awake and doing something, let's have a look at these and just consider what's going on in these four cases for seeing. On the top left, we have someone who's jumped out of an airplane. They have a GoPro on their head, and you can imagine watching the GoPro video afterwards on your phone. But I think you'll agree that watching a GoPro video on your phone is not quite like jumping out of an airplane, right? The experience of actually falling through the air, imagine the ground rushing up, your head's moving all around like this. There's nothing fixed or static about this. And the GoPro is a hint as to what it's like to jump out of a plane, but doesn't really capture it. So seeing in this case is nothing like a movie. On the top right, we have another kind of seeing which is very purposive. We call it reading. It's difficult to know what to make of reading, but it is a form of seeing. And while you are reading, certainly it's not like there's a film going on. Because when we think about perception, we often seem to put ourselves in the position of someone in a cinema. So there at the bottom left, we've got a bunch of people in the cinema and they're looking at a wave, but they're not going to get wet. And they're all having more or less the same experience. They're all oriented in the same way, and that which unfolds is kind of common to them all. So, and when we think about perception, we tend to think as if we were sitting in a cinema. And then down the bottom right, we've got two wrestlers. Can you imagine what seeing is going on while wrestling? It certainly has nothing image-like about it. So when we speak of seeing, we mean all of these, and we mean more beyond it. There's a very important sense of seeing, which means I intuit directly in a way that I can't doubt. This is what mathematicians mean when they say that they see the proof. So you show someone, you make a claim about a theorem, and then you walk through the bits on the board, and when you get to the end, someone says, I see it now, by which they mean understand directly, intuitively. So the word seeing harbors all these senses, and probably many more. Likewise, there's no single way to speak of knowledge or knowing in all these cases. Now, the approach to visual perception that has got most attention is that done in the computational theory of mind. Some groundbreaking work that was given the Nobel Prize in 1981 was done by two scientists called Hubel and Wiesel, And it was the origin of the work we looked at in the previous video, where you record from single neurons as things change on the retina of an animal. That work was done with anesthetized cats. So you've got cats who are given anesthetic, so they're not behaving, they're not responsive, they can't move. And then you prop open their eyes, like poor Alex there in Clockwork Orange. And you have a screen in front across which you move various patterned elements, and you watch what co-varies in the brain. It's a very sensible occupation as long as you don't think you're capturing the whole of seeing like this, because the cat, importantly, is not moving at all. So some observations about our general approach to seeing have been made in this line, and that is the body of work done in the computational theory of mind in most cognitive neuroscience. But others have looked instead at people who are moving, animals who are moving, engaged in things, who are busy doing things like skydiving or wrestling. And they've asked, well, what way does the visual system work here? How does the interplay of light on surfaces facilitate what's going on? So some observations have been made under these conditions, and that such very different ways of coming at seeing should result in incompatible stories, or stories which don't join up, is perhaps less surprising. And when we realize that by seeing we mean a lot more than going to the cinema, we shouldn't expect a simple story. Now, all sides agree that, for example, knowledge plays a role in seeing. Seeing is not just the interpretation of meaningless pixels. Knowledge plays a role in what you see. And there are different ways to think of this. On internalist models, those that look to what's going on in the brain and that see the brain as building a representation of an external world from sensory input, and see the brain also as the locus of knowledge, of a lot of knowledge, high-level knowledge, then the talk comes of the influence of top-down and bottom-up processes. So perception or sensory experience is presumed to give the current input, but that interpretation is then modulated by prior knowledge, which is assumed to be stored in the brain. Now, there's a lot of puzzles about that language. It's not entirely coherent, but it provides a robust way of talking as we try to make sense of, for example, patterns of activation in the brain. So this interaction of top-down knowledge, presumed stored, with bottom-up new sensory input, then resolves to an encounter with the world which is shaped not only by the patterns of light, but by prior knowledge. How would this look? How would we say prior knowledge works in a relational framework? Well, this is perhaps less visual, but here's a person playing the saxophone. And when they come to the saxophone, they make meaning with their fingers and with their lungs and with the saxophone. There's a sensory component to this, in touching the saxophone and hearing the sound, maybe even in seeing it. But whatever's going on between this person and the saxophone is the result of a prior history of meaningful encounters in which the person and the saxophone fine-tune their relation. So that when this person meets the saxophone, there's a lot of history there. It's a history of encounters and interactions. So there's no sense in which what goes on comes out because knowledge of how to play the saxophone is stored in the brain. Rather, the knowledge can be made manifest only in the presence of a saxophone. Likewise, your knowledge of how to tie your shoelaces is not stored in your brain because it has no reality unless your hands are engaged in tying shoelaces. Just try this. To see this, try showing a child how to tie laces. The first thing you have to do is tie laces the wrong way around, and it's a bit bizarre. Anyway, let's have a little experiment. I'm going to show you a picture, and if you haven't seen this picture before, you're probably not going to know what it is. It's probably unrecognizable. Now, this might not work. Maybe you've seen this before, but if you're looking at this, you're getting sensory input from the screen, and it's not resolving into knowledge, right? But now I'm going to show you a second picture, and then go back to the first, and what you see when you see this again will have changed. Okay, so assuming that worked, I can't tell. Here's a little help. Now when we go back, you see the frog, right? So your prior experience has influenced what you see now. That's a challenge to all kinds of accounts of vision, but we need somehow to take account of the fact that our history, our past experiences, our knowledge, however you define that, influences what we see. So we've only indicated two large schools of thought here. There are others, but these are the two main ones at the moment. On the one hand, we have the computationalist view, internalist, that is interested in what's going on in the brain. And that body of knowledge is a laboratory construction. It's obtained by putting usually people, sometimes cats, into a pathologically still state, stopping them moving, and then changing the distribution of light in some way and recording what's happening in the brain. So there's a strict separation of the notion of perception from action, because while you're told to sit still, you can't be doing anything. If taken to extremes, this kind of view can lead to the unfortunate claim that you have no knowledge of the real world and everything could be a simulation. This is a popular view in some circles, in some theories, neuroscientific theories. The neuropsychologist Anil Seth, if you've ever heard of him, is one particular proponent of this. We call that neuroconstructivism. It's the belief that your perception is happening in your brain and is not directly perception of the world. And I find it very philosophically unsatisfying, I must say. But we all have our favorites here. And the other body of work we looked at starts with the body in the world and looks at the relations between them. So this is the ecological theory of vision. It's an embodied theory and it emphasizes relations. It's very hard to conduct experiments here. They can be done, but frequently it's observations made in the wild while animals or humans are actually going about their business. They're behaving, they're doing something. That's the situation in which such observations are made. And while we've had some very important results from there, and the diving gannet result is a nice one, for example, this approach has difficulty in speaking coherently about particularly human forms of abstract thought, for example, or what we might call high-level cognition. So these two stories don't join up completely. The embodied approach is very naturalistic. It's aiming at a general model of what we might call animal vision and not specifically human vision. So I don't think we'll ever get to a theory of reading there, for example. So I'm sorry if the landscape is confusing. It just is that way. We mean so many things by seeing that people have investigated this in a variety of ways, of which these are currently the two most influential schools. We're going to move on now and have some look at some optical illusions in the last video.